How's it going, everyone? Welcome. I'm Leonardo Gonzalez here. So, today, let's take a look at this last chapter of the scope and closures, the model pattern, and to understand how do I get here just by asking a simple question. What is this? And by this, I mean, what is JavaScript? How this JavaScript works. And I am here not because I really love about JavaScript in itself. It's because I love more is to understand my problems, and that's it. That's it. Because if I want to solve my problems, this something that generates emotions anytime that I have to interact with it, especially emotions that are detrimental to even to my own health, right? If I don't know, if I don't understand how the things work, it generate all of this kind of destructive emotions, right? Or emotions and actions, behaviors that what it does is just to prolong the suffering in not knowing how, for example, JavaScript, CSS, HTML, and HTTP works. All right. So in other words, that's why I'm doing this series of videos, and not from a standpoint, not from a rage standpoint. It's just from the standpoint of truly understand this. Now, so here in this model pattern, I went through understand the scope and closure, because JavaScript, since it is a language made by Brian, oh my god, beep, beep. Yeah, the name of the founder will come up later, but he create now is Brendan H. I know that's also is also always happen, right? So Brendan H creates is this language, right? Because now when he was working at Netscape, this company that now aims to develop is a applications known as a browser, right? So they need to have a language that provide is basic interactivity to documents. For example, like what you are seeing in this moment, right? So interactivity, like, hey, if I hover here, if I click here, and so on and so forth, right? So this language that initially was called Mocha, and the name of JavaScript come from a marketing shenanigans by position this language as a lightweight alternative to Java. And now the legal trademark that initially was held by or initially was held by Netscape, and then Netscape was sold to AOL, and through a series of acquisitions, right now it belongs to Oracle. So Oracle at this point, Oracle and all of the previous companies at this point, they haven't enforced the legal trademark. So no matter how you call this language, JavaScript, ECMAScript, 262, or ES, and the name of the year, so all of them are valid way to describe is what is this scripted language. So as the year passed, and now people around the language started to create more and more ambitious applications, right? No simple HTML documents. Now the industry started to grow and mature at a point that, hey, we need to actually define some sort of standards here. This is what we have is this spec oversees by a TC39, which is the technical committed group, that through a series of stage, right, they make a proposal to pass through all of this all the way up until it is approved by until it is approved and part of the spec. So now, in order for us to understand that JavaScript is an environment that initially was designed to run on the browser, and then now you can run on different environments, whether it's on the server, on the light bulbs, on robots. So, but the only reality that matters is on the web. Okay, so because this is something that the TC39 group, or they said meetings rough 2 months or bi-monthly, all right, and sometimes those proposals are accepted twice a year. Browser implementations, they have to stick to this spec, and they implement their own features at their own pace, right? They implement all of these features at their own pace. So Safari is well known to not go along with this spec so fast like Google or Mozilla, right? So because of this, now some features that might work in a particular browser but not in others. So because of this, we have this thing called polyfills that are now, as the name suggests, right? There are shims making us as developers use those future, aka, or this spec behaviors in any browsers. So if we want to understand now how this JavaScript engine works, by looking at how the language was created initially as a scripted language, aka similar that you now, I don't know if you have experience reading some scripts for any expositions or even on the entertainment media, right? So they reading is a teleprompt, or they memorize is some of their lines, and they have to they'll at a particular moment describe that. This is something that you see a lot in the TV and movie series, right? So it is this sequence of one after the other statements, which is JavaScript. It is. There is another language as well, for example, Python. I do think Ruby as well. But the thing here is that this feature of the language, which is important in asynchronous language or in environments that we need to wait for the user inputs to do something, okay? It turns out that now JavaScript has evolved to become something completely different, right? And something that is more relevant to what is needed in the web development applications. Not as a scripted language that goes and analyzes one line after another, but into a compiled language when it comes to analyze code, not to generate. So I also look at as the industry evolve and see that, and to check if JavaScript is a fast language, right? Because due to this scripting nature, it turns out that a bunch of Mozilla engineers back in 2011, so they say, hey, let's take a look at the JavaScript that's going to pour these Unreal game engines by creating a subset of JavaScript or a superset of JavaScript in this case that targeted specifically the JavaScript engines for further optimizations and execution of our code. So now we can enjoy that hard work that they create now this language called ASM.js, that allows to port now this Unreal game engine written in a different language like C++ into and now execute this in web browsers. So years later, now a bunch of other Mozilla engineers and other engineers across different the web industry, the browser web industry. So they come up with this spiritual successor language by saying, hey, instead of create a subset of JavaScript, let's going to skip the parsing phase by creating this intermediate representation of the language, like an assembly-like, right? That is much closer to how the machines actually works, and it's moving is one register to one place another, and do some arithmetic operations and logic and arithmetic operations, and move register from this, and the return now is going to deposit in a new register, and so on and so forth, right? So if you think that you can program complex stuff like that, I don't think that it will take me too much time, right? It will take me a lot of time to build, for example, basic stuff like a calculator. So because now with WebAssembly, it now is a universal compiler target by saying is, hey, what is the application language that you want to transform into this WebAssembly, that anytime that you have a WebAssembly runtimes, as long as you pass me this code, I will be able to execute this. So for example, Netflix and other these companies, they are using that for video processing and video and image and audio processing and some other things as well. So, and as the JavaScript evolved up to what is today, and because as the programming in itself come from these small single applications that allow you to detect when the user detect a button, right? I'm talking about is in the 90s, you have the one single document there, right? It allows you to detect some small inputs. So for example, is when the user started to type on an input or detect a buttons, send that data via a form to a server. But as web applications now starting to provide more and more interactivity, well, for example, with social media and so on and so forth, there was a need to provide hints to the JavaScript engines of optimizing and running our code. This is known as the use strict, which is change the semantics of how you're going to write your programs to have a better chance of optimizing and running your code. So this is just a high level overview of JavaScript. And then now the more technical aspect, and I'm going to briefly mention stuff like that because again, what is relevant here is the model pattern in today's video. So in order to write our programs, we need to understand what a program is, how JavaScript see a programs, how JavaScript actually make different programs or aka files to cooperate amongst them. What is a program? Which is a set of statements that allow you to represent and to generate some output, desired output. Okay, it's an application of these mathematical backgrounds and language, right? Applications like a calculator or an animations, or for example, this website where you want us to now host several things here. Hey, the code, the issues, some pull requests, some actions, and some different views. So code and blame and so on and so forth. So different features that you can go with, at least for this website. So if you go for another website like GTA, 6, I do think is this, right? What is the website? Rockstar Games is this one? Websites like this, right? When you're starting to need to provide this kind of interactivity, hey, here I'm showing is, hey, we are loading all of these assets. It's quite slow, but depending on your connectivity, is this. So to actually show this one, right? Provide this kind of highlights, and then navigate through the content as well. Show this kind of content in this fashion, right? Um, um, I do think that's interesting. I do think that they changed that a little bit. Um, yeah, I do think they changed that a little bit. Um, uh, um, so and this kind of interactivity for that, is like when you hover an element, you're gonna see this. I actually never really check out this website, right? This is the first time I went through this. In all of these images and interactivity here, and how these small animations and so on and so forth, you can see. Oh my god, that too, bro. Anyway, don't do that, girls. Anyway, who am I to judge? So, uh, so, so yeah, this is quite interesting. Um, but again, if I click here, exactly. So also to show now videos like this, right? And they actually changed this. I don't know why they changed this. Yeah, and they changed a lot of it. Is this animation? But in any case, yeah, it's quite interesting. If they detect my internet connection is slow, now they show me this content as it is. But if I try to reload this, right? And this kind of effect as well. So in any case, why am I showing this? It's because again, this content that is being consumed by people like me, all right, and then wants to provide more and more interactivity to your applications and more relevant content to them as a way to capture their attentions to sell something. Most likely is this the whole point of this. Uh, well, this is why our programs have to evolve here, and this is what a program is, right? For this particular application. So in order to understand the technical aspect of our programs, we need to know about is the values, what a program holds. What is the thing that it can represent this program? Particularly in JavaScript is, well, primitive, whether it's a string, a number, and how they are represented by the computer. So you have another string using now, right now the UTF-16. Prior to that, you use now the ASCII, which is a huge table that describes is the number and the proper symbol that is attached to it. So it map all of these different symbols, ASCII from the English character and the UTF from the whole world. All right. So mapping these characters across Western cultures, Middle East and Africa, Sub-Saharan Africa and Mongolia and Asia, in Oceania. It is known as in some basic icons and emojis, right? It's known as the uh, basic multilingual plan, right? And anything that go beyond that, right, is known as the astral plane. What you have now is combination of emojis and other different kind of symbols. So this is what a string is. We also look at the numbers and how now numbers are represented here using the IEEE 7054. So it's a way of how you can represent up to a number followed by 13 zeros, something like that. But in any case, this particular way of representing number, it is fixed nature, is something that introduced now some particularly bugs like 0.1 plus 0.2. This is again, it goes beyond the scope of today's video, but I'm gonna leave you to do that, right? Check that out, okay? Check that out, and tell me what is the value of this and why that value gives you that output, or why that operation gives you that output. In any case, the other is let me now is explore the different type of primitive. Now booleans and big int and kind of emptiness, undefined and null, and also the objects as a way to represent is now complex data. So for example, objects like hash maps, all right, or these two column tables. You have the key and the value, and the value can hold now is primitive, and also is other objects, arrays, sequence of elements, right, and functions. And functions are one of the initially complex topic, because it is hard to wrap your mind around this initially if you're new to this. But it turns out that it's quite powerful, because now if a language allowed to support now a set of instructions in one single bundle known as a functions, so it unlock now other patterns here known as functional programming. So here I look at how to work with that, how you can define these functions, and where you can define these functions, how you can hold that inside of variables, and what a variable is. Working with variables is another thing that is very, very important. So also how you can play, or what are the operations of this kind of values, right? So you can compare them, if they are the same type, what's happening, if they're the different type, what's happened. The language has, I think, called abstract operations that allow you to actually run this when those scenarios happens. Okay, so hey, if these two values are the same type, or if they are the different types, right? And what happens when you try to convert one value to another value, all right? And when you compare these two values, there's something known as the referential equality. In other words, primitive values are compared by their values, but objects values or complex data, complex values, object values, now are comparing by their reference here. And this is, for example, if you want to compare now is the content of those objects, of those values, now things started to become a little bit more work, right? Because the language doesn't support that. In any case, and also is after we know how to do so, how to work with these values and how to interact with this, then it is also important to know how to organize our programs and what are the ways to do so, whether it's by functions, by models, or by class. And then some of these low-level features that the language now provides. So for example, like the iterations. So what is the iterator and iterables? Why do we have that in the language? Okay. Again, this is a particularly pattern from the sign pattern that it has been shown so powerful that now it is embedded in this language. So we don't even have to think about that. The iterator pattern. So regardless the way how you have your data organized, regardless the topology or the shape of that data, right? I just want to find a way, find an algorithm to iterate through those elements, right? So this is known as the iterator protocol. And the other is the iterables, which is described as that this kind of objects now that has implemented this batch, these iterables, so you can now access to them via the iterable, so via this syntax that allows them to consume. So for example, for loops and iteration and so on. Another thing is the looping syntax, right? This is more like basic stuff. So how do you declare variables, what our variables are, looping syntax, conditional syntax, and then is the specific things of this language. That is, what is the value of this? What is a closure, which is our part of the anatomy that functions? And when we look now at object is how you're going to access to property that now has a link to that, right? Known as the prototype object oriented. This is just to describe is the synchronous nature. And then the asynchronous nature is to say, how do you now deal with eventual values? And it's important to know the distinctions of parallelism and concurrency, that as you're starting to develop your application, and it means that when you now call apps like Rockstar, right? So because all of this data live in somebody else, in some server out there, somebody else, right? So now there is a latency, there is a time that you need to wait for that. This is why I see this, and also because I'm downloading a game right now. That's why I have slower internet connections. But the thing here is this, and how do you now handle, what are the things, what are the tools that we have right now in order to know how to wait for this data to be low and then show the entire content as it is, right? So without and indicating the user, hey, something is going on. So here, please stand by, right? This data doesn't hold locally, so we need to go to that server that whatever it lives, and they now load that content here. So this is part of the asynchronous nature. So it is important at least to understand what is the difference between parallelism and concurrency. And parallelism is when you want to have a task that, to run at the same time. You want to now have multiple tasks that you want to run at the same time. And concurrency is tasks that overlaps at a time. A good example of this is that if you are now at the kitchen preparing a meal, and then somehow now your mom calls you, right? So you have to stop whatever you're doing in the kitchen, and then hang on the phone and start to talking to your mom, while also then go back to the kitchen and do whatever you're doing there, right? So this interruption that can happen as you do a task this is known as concurrency. So this concurrency, or these events that can happen here, we need to find some way to handle it, to deal with. So in JavaScript, first we have things called like callbacks, right? As a way to, when you now, when that data is available, this is the set of instruction that I want you to pass down as a callback or as a function. And then is, all right, so because this requires a lot of coordinations, especially if you are now handling is several interruptions. Now with the same example of the kitchen, so you're in the kitchen talking to your mom, and then your dog is there fighting a cat, right? And then is making a huge mess in the in let's say in the living room, right? So you have to deal with another interruptions. You know, it's like, how do you actually here do all of these things, handle this, right? So it turns out that in the case of computer, right, this is a coordination problems. So I'm going to still, pending of whatever meal I'm doing here, I'm going to leave that in a particular state that doesn't get burned, right? Well, I'm still talking to my mom and say, hey, hold on, I had to deal with another stuff, right? And then you go, right? Separate the French toast cat with the dog, all right? So put them outside of the house, kill them outside of them, close the door, come back to the kitchen, and now you have in a different state of the kitchen. Everything is still warm, and almost about to get overcooked. So you slow down that. So you slow down the fire, and now you're still talking to your mom. So this sequence or that happens, right? It involves a lot of coordination and prioritizing of work and all that kind of stuff. It is quite my bending. So in the case of programming, you say, hey, how do I deal with all of this eventual value that I know at some point it will come up, especially here. So how do I deal with, for example, is these icons here that is live here, and this image as well, and loading this another image, and this text, and so on and so forth, right? How do I deal with all of these different assets that I know that at some point it'll be here, but I need to coordinate that and show them in the proper order, right? This is what I really love about this stuff, right? Of GTA, GTA, right? This is what I really love about GTA. Fishing? that's so gringo. I never fish, bro. That's so gringo, or Argentina, or any people that have a lot of money and free time, you know. But in any case, again, I'm not blame them. I'm just describing something that it is weird to do that in cities. Anyway, cities live their own bubble. City live their own bubbles. So in any case, this is the reason why dealing with this series of eventual values and understand that this is a coordination problem, and to do so manually is requires a lot of line of works. So it all starts, okay? So this concurrency stuff, or with dealing with callbacks, it now not only that we have to deal with two stuff, the coordination problems, and to show them in an orderly fashion, right? And also handle with time, because at some point this kind of data will come up, I don't know when, but they will. And when that arrives, I need to deal with them, right? So this is now becomes also a time problem. So people in the 60s, they now develop some particular techniques that they say, hey, let me now hold that information, and once that information is available, I'm going to run this task for you, right? This is known as thunk, and also I call that async thunks, and how to create this, which is some people say that they don't know what they were smoking, but I do think that it is not about smoking, it is about the desperation of solving something, right? Of understanding and solve that. So yeah, this is now thunks. And then we have now something called that promise here. And promise come from the promise in JavaScript. What is the mathematics involved? Promise is now a monad, or is almost a monad. It's almost a monad. Is promise a monad? I don't know what a monad is, but what I do know is monad Wikipedia, but I do know is that monad is a concept from functional programming. Now we'll give it is that in English? Yes. It's a concept from functional programming. Okay, and this functional programming is the composition is a programming paradigm, right? Where programs are constructed by applying and composing functions, right? So now you have, instead of doing that in an imperative way, right? You are now going to create your programs by applying and composing functions. Why this is important, you may wonder. To understand is this, because now it will give you now certainty by relying on mathematical concepts in applications that prove that works. So that's why we are. That's why I'm looking at the monad. That's why I mentioned is a promise. So promise is coming from the functional programming. Is this way of writing our programs by applying and composing functions. Okay, and the whole point of this is to have now certainty that this specific part of our programs now, by following these mathematical principles, it will work, and it will make our life much more simple to maintain. Again, not everybody can have or not all programs can be functional, because at some point you need to interact with the outside world, right? And this is when the object-oriented programming kicks in. So when you combine now object-oriented programming with functional programming, so a lot of the time now it's what makes your application much more easy to understand and robust, and of course to maintain. So this is why I mentioned promise. Okay, so promise is somewhat a monad, and a monad is a programming concept from functional programming, which is, hey, let's going to create our programs by applying and composing functions, because in this way, by relying on the mathematics, we now have much more certainty that our programs will work the way it is expected. This is useful for computations, but when it comes to cooperate with other programs, that's why we have another paradigm, which is the object-oriented programming. So in any case, so promise is this, and promise says, hey, I'm going to now provide you an object that allow you to now to deal with these single eventual values. And once you get that, you can now is extract that information and do something about. And also you can chain computation with that. There is another so some problems rise with the there's a couple problems that rise with promise, especially when you want to write your programs in an asynchronous way, and now those callbacks or functionality that you pass to these chains of events now live in different part of the programs. So now it becomes quite hard to actually understand what this is asynchronous computation is doing, right? So this is now we have is things like generators, that what it does is to say, hey, let me now pause the execution of these functions, and at some point in future I can resume the execution of these functions and then now continue to evaluate that. That is very interesting stuff, by the way, because with generators you can create your own async and await promise. So you can create your flows there, and relying on promise as the plumbing for anytime that you write your applications using the async and await. So you can define all of this asynchronous computation in a synchronous fashion. So that's very, very interesting. And the other is that what happened when you, this is another problem in asynchronous computing, is how do I now here deal with series of eventual values, right? So again, we have another pattern known as observables that allow us is to plug into a source event that is going to broadcast several of these values at some point in future. We don't know when, but all of this, so you can subscribe to this promise like that is emitting several of these values at different points in time, right? And then you can apply now some sort of transformations to this data, right? So this is just to describe this asynchronous nature. There is another one, another paradigm, sort of speaking, is known as the communicational communicational sequence process, right? That is something that language like Go are now using heavily to describe patterns of interactions in concurrent system. I don't know what they have this kind of stuff. Yeah, it's like what the French toast anyway. But it's this, right? It's a formal language, aka is a description language. It's a language. It's an alphabet, right? That's interesting. So communication sequential process say, hey, this is now an alphabet, a formal language that describe pattern of interactions in concurrent systems, aka in systems that at some point you need to deal with some eventual values. It's an alphabet to do so. Holy fuck. That is a mind-bending stuff. Jesus, French, those guys. Okay. So as well as secure e-commerce system. The theory of CSP itself is also still the subject of active research, including work to increase its range of practical applicability, increasing the scale of the system that can be tractably analyzed. So again, all of the things that I mentioned, right, which is to understand the current stage of JavaScript, right? Uh, is this, and I spent 45 minutes to describe what took me is from October. Holy shit! That took me is 1 year. Jesus fucking Christ! 1 year and so 15 months. So what took me 15 months. So now I can summarize is what took. So not only that I can summarize, I can describe that in English, in a plain old language, using now real life analogies. So what took me is 15 months to understand, truly to understand this. All right, and thanks to Kyle Simpson. Shout out to Kyle Simpson and among other developers to describe in 45 minutes. You know, holy fuck. Holy French toast. Oh my god. All right, good. Now, to what really the whole point of this, right, is to finally get into the model pattern, and that is by looking at the part of the language that is relevant to scoping and closure. So anytime that you want to develop an application, right, it is important to define is the well-defined scope, because then we can see if that works or not, and we can iterate on that. All right, so far so good. So it means that in order to understand now the programs, scoping is a very important topic to understand. Understanding it especially is that how you're going to work with variables and how those variables can be accessed through your entire programs, how those values that are held inside of those programs can be accessed through your whole programs. And this is why when you are writing your programs, and because now functions are part of values that you can hold inside of your variables, so the way how these variables, block, and functions interact with each other are defined by a rules known as the scope rules. So the functions, statements, and these variables and this relationship is determined before the code is executed, right? So since the structure of this relationship, whether it's a block, function, and because functions allow you to define now variables or container of values to describe a series of statements that do something, and they can be held inside of another values, right? So this structure that is determined at compile time, it is not modified by runtime conditions. So AKA is creating a closure. So AKA is now creating is a closure, is a place where now you can define a function, and if that function have reference to other function, to other variables outside of that function scope, you can now still continue to have access to that values or variables inside of that function. All right. So this is why, in order to understand this, we look at the classic how the language actually works. So by looking at the classic compiler theory, that is made of three phases, which is the lexical and tokenizer, which takes all of these characters and transform into meaningful tokens in the alphabet or in the language, right? And then now parse that, aka it's going to take all of these strings of tokens and see the relationship among them to create now is the abstract syntax tree, all right? And then usually on the final stage, stage three, is generate the code, usually, right? In a particular platform, in a portable binary program, right? So that platform can be iOS, or Mac, or Windows, or any of this huge myriad of distro Linux. So you get the idea, right? So yes, it's pretty basic. Basically, is that. So, so in order to understand that, in why this is still relevant, is because when you are defining is the relationship, or when you are now holding values in a variables, and these variables are defined in a particular scope, whether it's a block or a function, this relationship is determined is via the lexical, aka at the first phase of that, aka when the words are defined. But the thing here is that because JavaScript doesn't work in this particular way, especially for the observable behaviors. So for example, like hosting, and when it detects now syntax errors or early errors. So this is why, by looking is at how JavaScript truly works, is like it has two phases, at least at 2025. You have the compile phase, and then you have the execution phase. But now the scope, right, that is determined at the compile phase, first it determine is the identifiers, and then keep track of all of these identifiers, or aka the name of those variables, all right, at the compile phase, and then determine is where those identifiers live in the scope on those bubbles, right, and what is the relationship of those, right, known as the scope change. And once that is done, right, then the JavaScript pass through the execution phase, and the scope manager still continue to interact with the execution phase, but this time is when the values are assigned to those identifiers. Okay, so by understanding is these two phases of the language that has and explain is these behaviors of having this initial compilation phase, and then the execution phase, and this now solves the mystery of hosting, for example, and how now syntax error happens, or why syntax error happens before the code is evaluated, or the early errors, right? So as we explore now is the how do I call it? Yeah, as I explore now is the different type of scopes that we have in the language, not only block scope, but function scope and parameter scopes, and the usability of defining is always your functions with the name. You can rely on anonymous functions, but they are not lexical. Okay? You cannot access to them via your code. You can hold that inside of a variable, right? But that doesn't mean that you can have access to that function specifically if you need that. For example, to do some recursion. And I know doing recursion in JavaScript is a no-no. Only for a small subset of stuff, because the language has shown that it's not quite fast, all right, in doing so. But in any case, we know that this is an important stuff to do so. When you, for example, needs to iterate through different collections of, when you need to iterate through a unknown data structure size. So AKA, let's say that you have a huge ton of paperwork, all right, right? You don't know the length of that. You can count that, but for some reason, okay, I do think this is quite interesting. So imagine that you have a motorcycle, and then you want, and then your motorcycle now, the engine doesn't start. So then you need to do a lot of heuristic, especially if you're new to motorcycles, because you don't know, bro, or sister, you don't know. You don't know what the French stuff is happening here. So you do need to have a lot of heuristic, that will take you a lot of time, all right? And if you do this, you have to inspect each one of the things that you need to go through that until you find that, right? So this is quite similar to what the data structure is. So if you want to find a specific data that is relevant for you, and in the case of the motorcycle is what the French toast happened with the engine of this motorcycle that doesn't turn on, all right? So you need to pass through all of these different stage until you find the problem here. And this is exactly what recursion is allowing you to do. But in any case, the thing here is that is what a how do you call it? I do think that is this, right? Okay. Okay. So, sorry. So I also look at another scopes known as the global scope. So this global scope, all right, that allow me is to how do you put it? Yeah. So this global scope, that the whole point of this is to act as a common place to share now functionality across all the different scopings, okay, or all the different scopes. So where those live, you have now the global scope in the browser. You can have access through the window. There are some specific behaviors that when you define, for example, var and functions, they are not attached to the window, to the global object. Unlike let and count, they don't do that. You also have the service worker. I am not quite familiar with how to work directly with service worker, but I do have experience to run some code there. So these service workers allow you to run some computations without blocking the main thread. Speaking of concurrency and the example of you preparing a meal, then your mom calls, then the dog is chasing the cat. You have all of this concurrent stuff happening that you need to deal with, right? So so you have now seen different threads that allow you to evaluate is one specific task. You have the main thread, which is the UI when the UI happened. The other is the service worker for deferring computation, okay? And this is another environment that it has now a self global, or that has a global scope. You can have access through the self property. Variables and functions also attached to the global objects, identifiers. Those identifiers attached to the global objects. Let and counts does not. Then you have another scope, the holy French, the the common GS and the ES6. So you can think of this like a function wrapping another functions that is providing certain properties to that scope, all right? And then once I know the ins and outs of the scope and how that works, all right, then we look at how variables behave in these different scopings. So for example, var and functions that now they host that, and then unlike let and const that they don't do that, how now var and functions behave in looping syntax, whether it's for in, for of, and the traditional for, and what are the nuance that happens in the for loop, and also uh, the the way how now the let and const behave. So for example, in a particular scope, in a block scope or in a function scope, and how now they are scoped by block. And you might wonder, why do we even care about this? Well, it turns out that a lot of the JavaScript developers in the web industry and the TC39 group agree that using, so it is important for us to sometimes redefine the or use the same identifiers across different scoping to do some computations. So by doing so, we actually is now shadowing the variables, aka the same identifiers in nested different scopes. Now they are belongs to a different scope, right? And you can have access to the prior the same identifier. Uh, exactly. So to avoid any of this names collation or value collations. So so let and const allow us to do that per block, and also let and const have this thing called TDC, the temporal dead zone, that when you're trying to referencing a variable using let specifically before it is declared, now you can have access to that, right? And in order to solve this, well, always put your let and const at the top of the block scope, so you can prevent this stuff. And the other is these things that I mentioned early, hosting. So when the var and function actually, when you use in a particular scope, all of them are hosted at the top of the scope. Vars are initialized with undefined, and functions with the value, with the function value, all right? And you may wonder, why do we even care about this? And it turns out that variables and functions, in the case of functions, when you're reading your code, you want to you want to understand the function execution first and then the definition. And in the case of var, is useful for holding some values that you might need at some point later on in your code. But this is just the justifications behind why do we have hosting, why can we now is define a function, why can we call a function first without, and then later on declare that, right? Again, this is something that Carl Simpson actually mentioned that makes quite a lot of sense in terms of describing is that, especially as the reader of the code. So you are reading is what this function is calling, and then what it does, what the definitions. This is just the reason. So once we understand the ins and outs of scope and the behavior of variables and how they work in different contexts or scopes, now our attention shifts to high-level thinking. What are the decisions and patterns that we need to do in order to organize our code? One of them is the principle of least exposure, coming from the principle of least privilege from the security, where from a architectural standpoint, when you have now several systems that are now talking to each other, and if one of them misbehave, whether it's by an attacker access, so on and so forth, the bare minimum connections that you have amongst each one of them, the less likely is to compromise the overall system. Now, what does it mean is that if an attackers get in and if an attackers, so let's think about in a house, right? So if somebody broke up your window, and if you have all of your different different part of your house, that the only way that you can have access is via the door, which might be quite fucked up because you need also windows. But if you can imagine that you have a house that the only windows are on the dinner, that the only windows are that you only have windows at the living room. In other place, you don't have that, right? And if you can imagine that an attacker or somebody broke up, it will broke up through your window, right? And if they want to have access to other different part of your house, they need to do that via the doors only, or they can bring up a huge hammer and turn and blow up that wall as well, right? So again, brute force is another one, attack. But in any case, the whole premise here is that the least connectivity you have between different part of your programs or your house, the less likely is for one compromised area is now compromise other ones. So in the case of programs, is by limiting the exposure, limiting limiting the overexposure of variables across different scopes, because now this will avoid is naming collisions, unintended dependency, and unexpected behaviors. So how we can do that is going to depend on your use case. Something that Kyle Simpson mentioned is that when you define your applications, right? Well, scope them by what are the things that are relevant to handle that. Do not use functions declaration in an if statement, because now your applications might enter into a wonky state. Depends on the engine. Some of them works in an unexpected way. So it turns so here is, let's go to now instead of defining is function declaration in an if block or functions in block, it's going to now hold that functionality in as a variable here. Check if that behavior exists, and if it doesn't exist, let's go to now is replace that functionality in that variable, right? So I do think this is something that you might want to go, especially if you are implementing some library, or if you want to provide some fallback, so on and so forth, stuff like that. And then, all right, and then now looking also or speaking out of the decisions and patterns that we need to organize our code. One of them is the principle of least exposure, and the other is closures. So closure is a behavior specific is a behavior specific of functions. So functions here allow us to access to identifiers that live outside of the function scope and execute that function in a different scope change of the variable. So the observable behavior of this is that I mentioned, and the other is the implementation. And that is, if you want to create now a closures, you need to is define the so referencing variables outside of the function. This function must be invoked in a different scope from the variable change. So another thing is when you create this closure or this reference, that what it does is to remember is values outside of that function and keep those variables around, right? So you can think of this like presetting stuff. And a good analogy of this is your keys, all right? In terms of if you set a key hangers or a key holders in the same spot in your house, you know that that will be there. So you are presetting stuff to do common stuff. Another thing is that, hey, if you have a fridge, on the top of your fridge, you put all of this red meat, if you're carnivore or omnivore, or even vegetarian. So you put all of this protein-based food at the top of your fridge to preserve them. And then when you need that, you consume out of that, right? But the whole point is that you set a common place to store something. That's the whole point of this closure. And you want to keep track of that. So closure here now give you a live is a live link here. So why am I mentioning this? Because anytime that you want to now store informations that you want to store and remember information over time and act upon that data, so closures allow you to do that. And it turns out that this closure is also is a helpful way to organize our code, right? In this small snippet things that we want to do. And if you want to create now new instance of this, so you can create all of this. Another caveat is that because those live link are attached to a function instance, as long as there is a reference to that function, those links will live. So to avoid any memory leaks, so you must get rid of all of those when you don't see fit. So all of this is just to describe that closures allow to organize our code around the values that we need to remember over time. That's the whole point of this. So if you find yourself in the need to keep track of that data or to store or remember this piece of data, well, it turns out that you can use a closure to that. So a good example is, hey, I do want to hold some specific data for any of for X, Y, and Z information. So these patterns that allow you to remember data over time is what is useful for holding user data, for example, across your application, all right? Or for any other relevant data that you want to store here in your application. So useful data are, for example, the user seasons, right? Another is the theme season, right? Any piece of information that you want to remember, closures allow you to do that. Another good example is, so because here at the work, we have now an issue to, so here at the work, I have an issue of firing up I have an issue when firing up a Jesus. I have an issue. This is the thing. Here's the thing. The user now is capable of typing. Right? So the user is now capable of typing, and then submit that. Right? It submits something. So, but what happened is, I do want to, once I receive that in the API, right? I want to somehow, if the user is typing something and send something new, all right? So new data. I want somewhere. I don't know when, but I want somewhere is to stop the previous one. Not stop the previous request. All right. Stop the previous request, aka save me computational times, and now do this new request. Stop the previous request and run the new request, which contains let me put it this, right? So Lauren Ibsen, right? And now here we have is dollar est. Okay. Stop the previous request, which is Lauren Ibsen. Okay, Lauren Ibsen, and run the new request, which is dollar est. Right. So if I ask now Claude about this, and you might wonder, is this still relevant to the closure or to the model scope and stuff like that? Yes, it is. This might go something beyond the scope of, but here we are. Okay. All right. Oh, they took away all of this powerful stuff that I have. Exactly. They took away. Yeah, they took away all of this. I just asking some interesting question about penises and anatomy. Anyway, but there you got it. Okay. So I do want to. I have exactly. So I have a problem. With React app and Node using GraphQL, right? So anytime a user send a request, okay, and then anytime a user send a request, and then after a small seconds, right? And after a few seconds, sends another request, I do need to stop the previous request. Exactly. I do need to stop the previous request and start start handling the new one. For example, so what is the name of this problem? There you go. Exactly. Identifying request cancellation patterns. Request cancellation and abort stale outdated this. The underlying problem you're trying to avoid is race conditions. Exactly. This is race condition where an older request might complete after a new one and override the more recent result with outdated data. Some related terms you might encounter is request abortion cancellation pattern, the solution approach. The bouncing, related but different, delays execution rather than canceling. Later requests win, describe the desired behavior. Request supersede preemptions. For React sites, GraphQL client use abort control with fetch API. If using Apollo client, leverage their built-in cancellation mechanism. If using other GraphQL client, check their cancellation API. For Node.js GraphQL server, the server can detect client disconnection and stop processing. Implement request cancellation tokens signals. Exactly. So my problem here lies on race conditions. This might go beyond the scope of today's video, by the way. But I do think that's also something that you're going to, or I'm going to deal at some point in future. And it is important for us to understand now closure and what is closure, what it allows us to, and why do we have that, and so on and so forth. So that makes a lot of sense, right? That makes a lot of sense. So here, finally, after an hour and 22 minutes, all right, let's get into this. All right, I'll be right back. All right, and finally, we are here. Okay, let's look and read about this. Chapter 8, the model pattern. In this chapter, we wrap up the main text of the books by exploring one of the most important co-organization pattern in all of the programming, the model, according to Giles. So we'll see modules are inherently built from what we have already covered. The payoff of for your efforts in learning the scope and closures. So we have examined every angle of lexical scope, from breadth of the global scope down through nested block scope. Okay, from breadth of the global scope down through nested, or down, from breadth of the global scope down through nested block scope into the intrinsics of the variable's life cycle. Exactly, understanding the lexical scope from breadth of the global scope down through nested block scopes into the intrinsics of a variable life cycle. Then we leverage lexical scope. Okay, so then we leverage lexical scope. Okay, then we leverage lexical scope to understand the full power of closures. And take a moment to reflect on how far you have come in this journey. So you have taken big step in getting to know JavaScript more deeply. The central theme of this book has been that understanding and mastering the scope and closure. The understanding the scope and closures is key properly structuring and organizing our code, specifically the decision on where to store information in variables. It all boils down to this. So the central theme of this book has been to understanding the scope and closure. When the scope and closure is key in properly structuring and organizing our programs, specifically the decisions of what information we want to hold in variables. And what these variables at the end of the day is representing, what is the values that they are holding, whether it is primitive as I mentioned before, or even functions, or objects, or collections. And how this now, by understanding is the lexical scope and closures, it enables us to understand how to organize our code here. And we'll do some integrations and make it easy for us to maintain. So our goal in this final chapter is to appreciate how models embody the importance of this topic, elevating them from abstract concepts to concrete, practical improvement in building programs. This is what these abstractions are now applicable. So you have all of this abstract stuff that help you to solve specific problems. But it's very, this is where you need to start from an example. At least this is how works for me. It works for me by directly by having this deeply interactions of the language and getting a real feedback out of this. And then, because as our knowledge or as you're starting to build application, as the complexity and the maturity in that domain is naturally inclined to understand what are the fundamentals, right? That is how you can actually learn something. This is also a thing that in the mathematics things, actually look upon, like to. How do you? That's interesting. How do you? Yes, like what the French does. How do you? Yeah, absolutely. Absolutely. So I'm talking here is what works for me. That's all. I'm talking is what works for me. And what works for me is by looking at something that works, and as you continue to do that, then you're starting to understand the fundamentals. And this is also for any story that you want to understand. So encapsulation and the least exposure. Encapsulation is often cited as a principle of operative programming, but it is more fundamental and broadly applicable than that goal. The goal of encapsulation is the bundling of co-locations of information. Okay, the goal of encapsulation is to bundling or co-location of information and behaviors together to serve a common purpose. So this is the encapsulation at the end of the day. So when you talk about encapsulation is to put everything that is relevant in this specific context, data and its behaviors. Another good example is if you're moving out, right? So put everything in a box that is relevant to that. So for example, hey, this is the box of bath stuff, from medical stuff, kitchen stuff, dinner stuff, and so on and so forth. Because now it is much more easy for us to carry over that and unpack that. Independent of any syntax or code mechanism, the spirit of encapsulation can be realized in something as simple as using separate files to hold bit of overall programs with common purpose. This is something that we see a lot in modern front-end applications. When you want is to know, bundle up relevant things in that domain. So for example, in a search list, when you want to have is the functionality, the style, and the markdown, everything in one package, right? Here and there, you move on. That's right. So this is the recent trend, is modern front-end programming to organize application, because it is so. So the whole point of this is, what is the thing that you want to do, right? And in the case of, this is from front-end development, but in the case of back-end development, right? So the thing is that it's more about processing, data processing, and stuff like that, right? And here, because data processing is what the language is all about, you started to think another set of problems. Similar in the case of the front end. So you started to think another set of problems. You started to have another set of problems. One of them is computation in the backend, and the other is the presentation. So we have in the model or in web development, particularly patterns known as model view controller, that so far has solved some of these particularly problems. And this is why now, if you want to share state of information across all of these different view, now the modern development has encapsulated everything in one single bundle. When it say, hey, this is the piece of information that I want you to show, the UI, and this is the data here. So data and its behaviors, right? As well as the markdown. So it makes a lot of sense here, right? So another key goal is the control of visibility of certain aspect of the encapsulated data and functionality. So two things here is organizing our code by putting all of the data and functionality together, and the other is by providing security, aka to limiting the overexposure of certain hidden details or private data. Recall from chapter 6 the least exposure principle, which seeks to defensively guard against various dangers of a scope overexposure. This affects both variables and functions. In JavaScript, we most often implement visibility control through the mechanism of lexical scope. The idea is to group alike programs, big together, and selectively limit programmatic access to parts we consider private details. What's not considered private is then marked as public, accessible to the whole program. The natural effect on this effort is better code organization. It is easy to build and maintain software when we know where things are. This is again the same example of when you're moving up, right? When you I don't know how you say that is in English. Moving out, or exactly when you're moving out. Um, in Spanish, exactly, mudanza. Exactly. Or relocation, right? When you're moving out, right? So when you relocate or you're moving out, right? So you put everything in one single bucket because it is much more easy for us to identify those things, and of course to maintain them, right? So the natural effect of this effort is better co-organization. It is easy to build and maintain or deploy software when we know where things are, with clear and obvious boundaries and connection points. It is also easier to maintain quality if we avoid the pitfalls of overexposed data and functionality. This is also true, for example, for some piece of information, some data that that you don't want to expose as well. These are some of the main benefits of organizing JavaScript programs into models. A model is a collection of related data and functions. Okay, so there are some of the main benefits of organizing JavaScript programs into models. First, a model is a collection of related data and functions, and often refers as methods in this context, characterized by division between hidden private details and public accessible details, usually called the public API. A model is also stateful. It maintains some information over time, along with functionality to access the updated information. Okay, so two things here. So a model is a collection of this data and functionality with a clear division, or with a division between what is private and what is public. And also is a stateful, so it maintains some informations over time that you can have access through the functionality here. A broad concern of the model pattern is fully embracing system level modularizations. There you got it. A broader concern of the model pattern is fully embracing system level modularization through loosely coupling and other programs architecture techniques. That's a complex topic well beyond the bounds of our discussion, but it's worth further study beyond this book. To get a better sense of what a model is, let's compare some model characteristics to useful code patterns that aren't quite models. Okay. So others useful co-organization patterns are there you got it. Co-organization patterns are namespace. So you don't hold any piece of information. You only host is okay, co-organizations here. So namespace, right? Your group is functionality, a stateless functionality, right? You don't hold any data in there. The other co-organization is via structures, data structure, like a stateful grouping. You have your own state, you have your data, and the functionalities. But here, you are exposing this all of the data, including private details too, right? So models are a stateful access control here. So to embody the full spirit of the model pattern, we're not only grouping, we're not only needing grouping and state, but also access control to visibility through visibility, private versus public. And let's turn student from the previous section into a model. And we'll start with a form I call the classic model, which what originally refers to revealing model when it first emerged in early 2000. Consider this as an immediately invoked function expressions. You are holding this piece of information here that by the time that you so you are immediately invoke this function here and pass now the value that is this public API, all right, which is now an object that hold is the get name, and get name here is a function that is holding is the records outside that is holding this record outside of this function, right? in keeping this data over time, right? So you store all of that as an identifier called a student, and then if you want to have access to that, you can do that. Or if you want to access to the public API, you have to do so here. I should point out that explicit student data being hard-coded into this model definition is just for illustration purpose. For example, this, because usually that data comes from a server. A typically model in your program will receive this data from an outside source, typically loaded from a database, JSON data files, AJAX call, etc. The data is then injected into the model instance, typically through methods on the model's public API. So how does classic? Oh, okay. So you load this information, and then you wait for the data to arrive to inject that data here. Notice that the instance of the model is created by define student immediately invoked function expressions. This IIFE returns an object named public API that has a property on it referencing the inner get name function, which in fact this function has a reference of the records that live outside of the function to run some computations, and the result stored in these variables that is later on now exposed to this. So you don't have to return an object with a function as one of its properties. You could just return a function directly in place of the object that still satisfies all the core bits of a classic model. By virtue of how lexical scope works, defining variables and functions inside your outer model definition, functions make everything by default private. Exactly. So you can have access to the functions unless you explicitly expose. So by virtue of how lexical scope works, defining variables and functions inside your outer model definition function makes everything by default private. Only property added to the public API object returned from the function will be exported for external public use. The use of an immediately the IIFE implies that our programs only ever need a single central instance of the model. One only single instance of this model, commonly refers as a singleton. Again, another pattern. Indeed, this specific example is simple enough that there is no obvious reason we need anything more than just one instance of the student model factory, a multiple instance. Exactly. But what if you need somehow to create now several of this instance, several of this data and its functionality here, right? But if we want to define a model that supports multiple instances in our programs, we can slightly tweak the code to just defining that as a function, right? And then call that so we can get that. Rather than specifying the defined student as an immediately invoked function expression, we just define it as a normal standalone function, which is commonly refers to this in the context of a model factory function. We then call the model factory producing an instance of the model that we label full-time. This model instance implies a new instance of the inner scope, and thus a new closure that getNames holds over records. Fulltime.getName now invokes the methods on the specific instance. So classic model definition. So to clarify what makes something a classic model, so there must be an outer scope. Yeah, there must be an, okay. So to make, okay, what makes something a classic model? there must be an outer scope, typically from a model factory function running at least once. The model inner scope must have at least one piece of hidden information that represents the state for the model, and the model must return of its public API a reference to at least one function that has closures over the hidden model state, so that this state is actually preserved. You likely run across other variations of this classic model approach, which we'll look at in more detail in Appendix A. So when you explore now the Appendix A of the implied scope, classic models variation. Chapter 8 explains the classic model pattern, which can look like this. Exactly. So here you are now immediately calling these functions, and whatever data that you are receiving here is going to be used for that, right? So you hold this private data and then you expose the public API. Again, data and it is functionality here, right? Notice that we're passing a student another model instance. It is as a dependency, but there is a lot of useful variation of this model form you may encounter. Some hints for recognizing this variation. Does the model know about its own API? Even if we use a fancy model loader, this is just a classic model. Some models needs to work universally on the browser and on the server. So where's my API? First, most classic models don't define and use public API. The way I have shown in this code, instead, they typically look like this. Okay, where's my API? Okay. This is how it typically looks like this. So they define a function that is going to receive an instance of that piece of data, whatever it is, okay? And then have some private data that on the methods is where it's going to access to that and expose that, right? So here your passing is the instance of that. So the only difference here is directly returning the object that serves as the public API for the models, as opposed to first saving it to an inner public API variable. This is by far how most classic models are defined, but I strongly prefer and always use myself the former public API for two reasons. Public API is a semantic descriptor that aids readability by making it more obvious what the purpose of the object is. Yeah, absolutely. So I'm using it as a semantic descriptor to make it obvious what is in this. Storing an inner public API variable that reference the same external public API object return can be useful if you need to access or modify the API during the lifetime of the model. Okay. So if you have now a reference, this is why having identifiers for anything that you do is something that might be useful, especially if you have to extend the functionality and let it on reference to that computation or that data. For example, you might want to call one of the publicly exposed function from inside of the model, or you may want to add or remove method depending on certain conditions, or update the value of an exposed property. Whatever the case may be, it just seems rather silly to me that we wouldn't maintain reference to access our own API, right? That's quite silly. Absolutely. Well, I guess. Asynchronous model definition, aka you need to, and this is another variation of the classic model form, is AMD style models, popular several years back, such as those supported by the required JS utility. So here you define now as a function that is going to first accept is a collection of where that model lives, what is the file, and now the functionality here. If you look closely at the student list, it is a classic model factory inside of the machinery of the define. Provided by required JS, the student list function is executed, passing it as another model instance declared as dependency. The return value is an object representing the public API of the model. This is the base of exactly the same principles, including how the closures works, as we explore with classic models. And then you have now the universal models here. The final variation we'll look at is UMD, which is a less specific, exact form and more a collection of very similar format. It was designed to create better interoperability without any build tool conversion for models that may be loaded in browsers by AMD style loaders or in Node. I personally still publish many of my utility libraries using a form of UMD. Here is a typical structure of UMD. Again, this is to create better interoperability for code that runs in browsers or in Node. Okay. Hey, let me now. So here what I'm doing is immediately invoke this function, right? That is going to accept is the name, the context, and the definition. This will be is the name, all right? And it want to check is this loaded by the AMD style loader, if this is a function, and for somehow you have now is the AMD. Okay, all right. So call this with this. Okay, so call this on the browser. If this model that I'm receiving is now in Node, okay, type of model here, which is something that again, this is less specific variation. So hey, if now when I'm going to run this function, the model exists. All right, so let's go. Let me now is call the definition here, which is call this function. All right, with the name and the context. Assume standalone browser script, where you have now the context here. You have now a hash here that you want to attach to. Okay, you want to now attach this functionality here. Okay, you want to attach this functionality here and assign it its value to that. So you want to attach now you want to have this functionality attached to a hash here. Though it might look a bit unusual, UMD is really just an immediately invoked function expression. What's different is that the main function expression part at the top of the immediately invoked function contains a series of if-else statements to detect the environment, the supported environments. The final here, exactly. So here's detecting the environment here. And the second one is now giving us, is now passing that data. Exactly, it's now passing that data to the first one. As it is the final this, right? Is say, hey, I want you to evaluate this expression here. exactly. This is now the data that is going to receive, the parameter that this function is going to receive. So there is no question that as of the time of his writing, ESM are becoming popular and widespread rapidly. But with millions and millions of models reading over the last 20 years, all using some pre-ESM variation of classic model, they're still very important to be able to read and understand when you come across. Okay. So that'll be all for the video. Take care. Bye bye.